Welcome as we continue our wonderful and exciting journey. I believe you are learning and finding additional mathematics as one that is very fun. My name is Nana Yawedu and you can call me Say Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In our previous lesson, we have considered how we can solve for quadratic equations by using the method of completing the square. In this lesson, we want to consider the nature of quadratic equations. We want to look at how we can determine the nature of quadratic equations. So let's consider this. So basically, when we are looking at the nature of quadratic equations, we see equations that are of quadratic forms, that they are equations that are of the form ax squared plus bx plus c is equal to 0. Now remember that to determine the nature of a quadratic equation, we must consider the end part of the completing the square. So when we solve for completing the square, realize that we get minus b plus or minus square root of b squared minus 4ac and all this over 2a. Now remember that what is in the square root will determine the nature of the quadratic equation. So we have b squared minus 4ac, right? So depending on the b squared minus 4ac we have, that is what will tell us the nature of the quadratic equation. Now when b squared minus 4ac, right, is greater than or equal to 0, then we have roots that are real, right? Then the roots of the equation is real. So for real roots, we even have two different types. You can have b squared minus 4ac being greater than 0. And in that case, you realize that the root will be real and distinct. And then we have b squared minus 4ac being equal to 0. Then the roots will be real and equal. So equal and real roots, right? And then we also have the situation where b squared minus 4ac is less than 0. And in that case, you realize that what will be in the square root will be a negative number. So imagine you have the square root of negative 5. Realize that the answer you will get will not be in the real number system. So we'll be getting things that are in the complex realm, right? So we get complex roots. So to determine the nature of a quadratic equation, remember that we must consider the b squared minus 4ac part, right, of the formula or of the method of completing the square to be able to determine that, right? So now let's consider some questions. So the first question says that describe the nature of the root of the following equation. So the first equation, we have x squared minus 6x plus 9 is equal to 0. So we want to describe the nature of the root of the equation x squared minus 6x plus 9 is equal to 0. So let's write out the equation. The equation is x squared minus 6x plus 9 is equal to 0. We can compare this with ax squared plus bx plus c is equal to 0, where we see that our a is 1, our b is negative 6, and our c is equal to 9. Now, so to determine the nature, we know that we must consider b squared minus 4ac, right? So we'll substitute the values of a, b, and c into b squared minus 4ac. It means that we get minus 6 all squared minus 4 multiplying 1 multiplying 9. So we get 36 minus 4 times 9 gives us 36. So it means that we get 0. So this implies that our b squared minus 4ac in this case is equal to 0. right? And so therefore we can conclude that, right, therefore the nature of the roots of the quadratic equation is real and equal, right? So equal and real roots. So for instance, the values of the equation can be x is equal to a, right? So it can be x is equal to a, and then x is equal to a, where a can be any constant at all, right? Which is real. So that is the nature of the root. So once we use the b squared minus 4ac, we are able to determine the nature, and we are able to see the type of roots of the equation, right? Now let's consider another example. So in this example, we are asked to describe the nature of the roots of the equation 2x squared minus 5x plus 3 is equal to 0. So in this case, the question given to us is 2x squared, right, minus 5x. So we have 2x squared minus 5x plus 3 is equal to 0. So we can compare this with ax squared plus bx plus c is equal to 0. So we know that our a is equal to 2, our b is equal to negative 5, and our c is equal to 3. So we use b squared minus 4ac. So therefore we get negative 5 all squared minus 4 multiplying 2 multiplying 3. So it gives us 25 minus 4, 2, 8. 8, 3, 24. So that gives us 1. So we see that b squared minus 4ac in this case is greater than 0, right? Because it's 1. So therefore we can conclude that the nature or the roots of the equation, right, are real and distinct. So this is real and distinct, right, root, right? So it is real and distinct, right? So this is the nature of the quadratic equation. Because we got the value 1, which is greater than 0, we can probably conclude that the nature of the quadratic equations are real and distinct. So let's consider the final one. So in this one, we have to describe the nature of the roots of the equation 3x squared minus 2x plus 4 is equal to 0. So let's consider the solution to this question. So the question given is 3x squared, right, minus 2x plus 4 is equal to 0. So we have 3x squared minus 2x plus 4 is equal to 0. So we will compare it with the equation ax squared plus bx plus c is equal to 0, where we know that our a is 3, our b is minus 2, and our c is 4. So we are going to use b squared minus 4ac. So we get minus 2 all squared minus 4 multiplying 3, which is a, multiplying c, which is 4. So in this case, we get 4 minus 4, 3, 12. 12 times 4 gives us 48. So 4 minus 48 gives us negative 44. So we see in this case that b squared minus 4ac is less than 0 because it's a negative number. And so therefore, we would say that the nature of the roots here, right, so the roots here are complex roots, right? So we have complex roots here because b squared minus 4ac gives us a value which is less than 0. So in this lesson, we've gone through series of questions to be able to look at the nature of roots of quadratic equations and realize that when we consider the b squared minus 4ac part of the quadratic equation, we realize that if it is greater than 0, then it means that the roots are real. If it is equal to 0, they are real and equal. And then if it is less than 0, they are complex forms. In our next lesson, we want to consider rational functions. We want to look at rational functions and consider what they mean. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.